Good afternoon. This is become Dr.B.Vijayakumar, SNS College of Engineering. The next topic we discuss from this video is hysteresis, hard and soft magnetic material. The brainstorming session, what is a hysteresis and what is a hysteresis loss? The introduction, the hysteresis means when a ferromagnetic material is made to undergo through a cycle of magnetization, the variation of B and respect to the H can be represented by a closed hysteresis loop or curve. That is equal to, it refers to the lagging of magnetization behind the magnetizing field. The magnetizing field H is applied into the ferromagnetic material, and if H is increased to H max, that means the maximum magnetizing field, the material acquires the magnetism. So the magnetic induction also increase, represented by OA in the figure. So this is a figure. So it starts from the middle of the B and H is start from O, then it's saturated, then it return in the opposite direction of saturated, then it completed of the saturation. So the one complete rotation to the form of flux density and magnetizing force cycle, we get the BH curve. It becomes positive and negative formations. So the magnetic field is increased from H max to 0. The magnetic induction will not fall rapidly to the 0, but fall to B rather than 0. This is shown that even when the applied field is 0 or removed, the material still acquires some magnetic induction. That is OB, which is called residual magnetization or retentivity. The residual magnetization, the magnetic field strongly is reversed and increased to minus H max. It's represent OC, so it's called as a coercivity. So the curve is BCD. The reverse field minus H is reduced to 0 and the corresponding curve BE is obtained, and by further increasing H to H max, the curve EFA is obtained. So the explanation of the hysteresis on the basic of domain. So the domain moment and the rotation of domain ball base we have explained in a hysteresis. So this all is in the curve of hysteresis to change of different domain ball moment and the domain rotations wise. The first is formed in domain so aligned after saturation. Then second one, when the magnetizing field is removed, the permanent magnet retained significant portion of the magnetization. Then third one, demagnetizing field direct demagnetization to 0. The alignment of magnetic domain toward a random direction. Then the final, the initial magnetization curve is formed. So this is complete rotation to the form of BH. So this is all the theory to form of BH curve. The applied field is removed. The domain retained to the original state is known as a reversible domain. When the field is increased, the large number of domain contribute to the magnetization, and the magnetization increase rapidly with H. Even when the field is removed because of the displacement of the domain ball to a larger distance, the domain boundary do not come back to the original position. This process is indicated as an AB. At the point B, all the domain have got magnetized along the EC directions. That is formed in a BC in the figure. Then the OD is a magnetization or retentivity, and the coercivity is represented from the amount of energy spent to reduce the magnetization, that is an OE. So hysteresis loss is a very important to after discussion of this hysteresis curve. The hysteresis loss means the ferromagnetic specimen through a complete cycle of magnetization, and the area closed is called hysteresis loop. Based on the area of the hysteresis loop, the magnetic material are classified in soft and hard materials. So the easily magnetized material is a soft magnetic material, and it's difficult to magnetize and demagnetize, that is a hard magnetic material. The hysteresis loss due to the large hysteresis loop, it's under the hard magnetic material. The loop is in a very low and loss is also low. The susceptibility and permeability is low in hard. The susceptibility and permeability is high in soft magnetic material. Then coercivity and returnability value is larger because the loop is larger. The coercivity and returnability is less because the loop is very sharp. So the eddy current loss is high and the eddy current loss is very low. This is all the different types of magnetic material to form of susceptibility, atomic magnetic behavior, and the example of susceptibility, classification of magnetization. So these are the reference I prepared from this PPT. Thank you very much. We discussed in another one topic in another one video. Thank you.